Here we have an example. We're not going to do this example in class. If you'd like to do it, it's there. There's plenty of examples, as you know, on this homework, so you don't have to do it. It's no worries. Now we're going to talk about angular speed, because after displacement, we always talk about speed, or velocity. So angular speed can be given in 3 different ways. It can be revolutions per second, it can be radians per second, or it can be degrees per second. Okay? Those are the 3 ways that we can do it. The second one is the most important. You see radians per second? It's the second one down. You want to highlight that because that is definitely the one that we'll almost always use. And the symbol there, the second one down, radians per second. The symbol that they're using there is Greek omega. It's just a W. If you just write W, I'm fine with that. There's not many other W's. Can you think of any off the top of your head?
In physics?
Any physics?
Weight? That is not really a real one.
Weight, no, capital W. Applies to force. Yeah. Or watts.
Watts.
Capital W again though.
Work?
Work.
It's all capital.
Very nice. All capital, yeah. We can't think of it, so sorry. If you use W, you're good. Okay? That is actually the Greek omega though. Okay? So, that's what we're going to use. This is called the angular speed. This is the angular speed. And it's gone. I switched to blue. Underneath of that, you see the formula. Omega equals final theta minus initial theta divided by t. And make sure those are in radians. Make sure those are in radians. You can convert to radians. Okay, you just learn how to. See the bottom there, linear speed? All angular speeds we can convert to a linear speed, meaning it's in meters. But you're only required to not know the derivation. So you can put x through all of that. You don't need to know the derivation. Okay, put an x through the very bottom. That means put x through right there. Okay?
Linear speed and r.
Yep. And here's the equation that I care that you know. V equals omega r. What that does is it relates your angular speed to your linear speed. That's how easy that equation is. Okay? As long as your omega is in radians per second, you can convert it to meters per second. Okay? I'm going to say again, that relates your linear speed or your velocity, right? This is linear. From one place to the next, that's the linear. That relates to your angular velocity, or angular speed, radians per second. And all you do is multiply by the radius of the circle that you're going around. Okay? So that's what we really care about. That's the one that we're going to use. Those other ones are just there if you don't want to convert to radians. You can use those other ones, but it's quite easier just to know that. Okay? Sound good? Let's do a problem real quick. I'm sorry about the color. I really fought with my computer for a long, long time to get the color correct, and it chose not to. I'm sorry. So you can read it on your paper, or you can read it up here. I'll go and read it to you. Make sure you can understand it. So, a race car engine. Yay. Can turn at a maximum rate of 12,000 RPMs, revolutions per minute. What is the angular velocity in radians per second? So, we're wanting to know the angular speed or angular velocity that belt is going around. Okay? To find that out, we need to write what we know in this problem. So, well, actually, we're just changing it. Sorry, we're just changing it. We start off with 12,000 RPMs. Revolutions per minute. How do we convert that into radians per second? How do you change minutes to seconds? Yeah, Yeah. You divide by 60. 1 minute
Seconds.
equals 60 seconds. And if I stop now, my answer would be in revolutions per second. And it also says I want my answer in radians rather than revolutions. How do I change revolutions into radians? 1 revolution equals how many radians? 1 revolution equals how many revolutions? 1 revolution equals how many radians?
2 pi.
2 pi. Yep. So 1 rev equals 2 pi radians. And that is how I'm going to convert revolutions per minute into radians per second. Just with those 2 steps. So this will be 12,000 times 2 pi divided by 60. None of this may mark as my end. Keep dropping them. And I will get 1,256 radians per second. Okay, that's 12,000 times 2 pi divided by 60. The second question is a little bit trickier. If helicopter blades were attached to the crankshaft while it turns with this angular velocity, okay, so the crank's happening in the center, helicopter blades turn around it. What is the maximum radius of a blade such that the sound speed of the blade tips stay below the speed of sound? Okay? So, that one's a little bit hard to understand. Think of that for a second though. A helicopter, okay, is spinning, correct?
Yes.
Where's my tennis ball? So, this will resemble the blades, okay? The blades are small, right? Right, are the blades small or big? Small, comparatively to this one. Okay? Stay. Yay. Okay? What we're trying to figure out is based on the speed of sound, which one of these do you think would create a higher angular speed?
Repeat that?
Which one of these do you think would create high angular speed?
Small.
What do you think?
Oh, anglers.
Well,
It's radians.
I'm going to leave that question open for a second, okay? I'm going to remind you to come back to it. On the last slide, I'm going to go over that, okay? So, which?
Distance.
The reason being is that's on the very last slide, okay? That's the reason. So let's go and go through this problem though. We can use an equation for this. Speed of sound is 343 meters per second. The equation that we wrote down is right here. This is actually going to pretty much tell you the answer. The velocity, the linear velocity of the blades, if that's in meters per second, that is the linear velocity. That is going to be 343 meters per second, and that will equal omega, which we said that we were using this angular speed, 1256 radians per second, and we are trying to find out the radius that these plane tips have to be in order to not exceed the speed of sound. So we solve for R. That's all that we're doing this one.
R equals V over W.
So, yep. You divide by 1256, and R will equal
V over W.
0.273 meters. Exactly. Okay? You guys are not allowed to sit next to the camera anymore. Sorry.
I forgot about the.
Oh,
Yeah, I figured the sound quality on there is pretty poor due to the conversation. I do have your conversation on camera.
oh,
It was good. It was doozy. Yeah, I'm just gonna accept it. So, this would be the radius of the blades. So, not too big of blades. Okay, 0.273 meters. Those are very big blades. Right out top. So, not very realistic. It's because this is so high. Okay. It tells you how